This will be lesson 7, the register subunit. Thank you for joining me since we've been able to move all through here down to this place. I remind you again, this is just not picture or diagram. This is a circuit that can be simulated using Logisim and develop code is on my website, or I'll probably put the link to the OpenCore project also. OpenCore is very wonderful for programmers. There you see standard industry circuit codes, Verilog and VHDL. So let me just quickly go to the register file and see what is there. So this is what the register subunit looks like. Now I'll zoom in actually. So it takes 5 inputs aside from these ones down here. Let's just discuss the first ones up here. These three here. These three here. Remember, the three of them is coming from the right back stage. They just came from the right back stage. So first is the register write enable. All these are registers. All these things here, they are all registers. Different, they're up to 10 or 16 or so. So, but the register write enable is used to open this multiplexer. So to open this multiplexer here, that is to set it to 1 to accept new data. There's an AND gate here also, remember. So this write enable is part of the AND gate. It has to be on. Let me highlight it so you see something. Let me highlight it. So you can see that the register enable goes into every single register here. So it's used to enable all these registers to be able to write to them. If it's off, the register is latched. You can see this the latching process here. The register is latched. So the register enable, and likewise this. So this one is more like the register selection. Is used to select which register. So now each of the registers has a particular number. Here is register 0, register 1, register 2, register 3, down to wherever the number ends. So whenever you give a particular register destination, this comparator compares it. If the destination is 0, therefore open this one, then we can write to this register. If your register destination is 1, then open this AND gate. And the register enable is selected also, remember. So two things need to be on. That's why we have an AND gate. So the two conditions must be set. The register enable and the particular register must be selected. If it's 2, this register select destination selector must select it here to be 2, and the highlighted register enable must be on. Then we can now select this particular multiplexer which we turn on this register. And if these conditions are met, then this register data will now be written to that particular register we are talking about. So that is how all these registers are being written to. Now to read from them, see now watch, they are all selected. The output are taken down. So let's go down and see how you can read from them. So another input comes again. Remember I told you this is coming from the instruction decode stage. I told you about these two inputs here. From the instruction decode stage decoder, the register select address, see them here, the two of them. So it's going to select two outputs, two registers. So they are all identical. This operation here and this operation here are identical. Depending on the value of the register, it depends on what will be selected from this multiplexer here. You're going to choose which of them is being selected to be read from. These input, remember, they are coming from the instruction decode unit, selecting which, so only whichever one comes out and is not equal to 0, take it out to the instruction decode. So this output is going to the instruction decoder. So all these things are what makes it a pipeline. Is the ability to be moving from one subsection to another. That's what makes it a pipeline. So that is particularly what I plan to demonstrate with this tutorial. Then someone will ask what is the essence, what does it do? So you as a designer will have to determine what you want to what you want it to do. So first of all, you have to change this instruction memory. That is the first and most important thing. Just the way you change your video card, depending on what disc you play, gives you a different game. So that is what this instruction memory does. So whatever here determines the instruction to be decoded. So first of all, to have this circuit do something useful, you have to first of all put the instruction to your test, plan it, decide what instruction has to go there. So when you've done with that, then you have to start deciding how you structure them also. Your data memory, what data has to be there. So so the essence of this MIPS is just to demonstrate the pipelining, but this is a very strong and powerful processor. Pipelining is known to help speed up processing speed. So it's the job of the designer to now determine to what effect, what use to put the particular circuit, how, which instruction you want to read and at what time. So that will be all for this tutorial, and thank you very much. Okay, sorry, the hazard unit. So let me just quickly rush over it here also. So I'll be giving the which is running low. I'll just give a brief description of this hazard unit. So it compares, remember when we met all these DST inputs, so it checks if they are ever equal to this decoding source comes from the ID unit. Anytime they are equal, it turns it off, else the instruction is always on. So this other unit, this pipeline store N is used to halt the CPU in case of any error. If not, is on. What if we go back here, you can find out that the pipeline store is what goes to the instruction decode enable. Where is it here? This is it. It goes to our instruction decode enable. You can see it at different places. My battery is low. I'll probably be hanging up now. So by the time you go through the code also, and with my little explanation, hopefully you'll be good to go in everything concerning this. Please kindly like, share, and subscribe to my channel. Thank you.